All right, today's lesson is on domain and range. And I think this is something that you guys and girls have probably talked about before. We're going to introduce it again because you're going to see it in a new way. All right? Okay, first, on the very first page, I want to talk to you about what makes something a function versus what makes something a relation. So we're going to tie that in, and then we'll go into why is domain and range so important, because it's kind of important to understand the difference between these two. All right, pretty much a relation is just any 2 points that have some connection. Notice right here, I want you to pick your pencils up right now. I want you to write this because you're going to have to draw one of these at some point. I want you to know what it is because it's really easy. You see a big oval? You see another big oval? And do you see lines connected numbers? This is what we call a mapping diagram. There will be a time on a quiz or a test where you'll have to do a mapping diagram, and I always have 2 or 3 students that just forget what in the world they're doing when it's really pretty easy. Here are my input values, 0, 1, 2, 3. Here are my output values. I am going to draw a line connecting an input to an output. So 0 is connected to -2. 0 is also connected to +1. Okay. If I come over here on this little graph, they've taken those points, 0 connected to -2, 0 is the input, -2 is the output. That would be graphed like 0, -2. So it's over 0, down 2. This is that point right there. Everybody see that? All of these points on this little graph come from the numbers used in this mapping diagram. Does everybody see? Any questions about that? Pretty straightforward, isn't it? And I'm sure you're sitting there thinking, well, I know where are we talking about this? It's too easy. Okay? This is just a relation. It shows how points are connected. That's it. Let's move on. All right. I also want to talk about not only relation, I want to go farther than that. Now I want to talk about things that are connected, but they're connected in a particular way. We can only call it a function if every x has only one output or one answer. Every x has only one answer. So it's kind of like this. Imagine an equation. You put in an x value. You work it out. You multiply. You divide. You multiply, add, whatever. You get 3 as your answer. Well, if someone else is doing the same equation, they shouldn't put in a number and get a different answer. You should only get the one answer. Okay? So every x can only have one y. Let me say that one more time. Every x can only have what? One y. All right? One y. Now, let's look at this new mapping diagram. Again, this is a new mapping diagram. This is a different one from the last one. But again, my inputs are on the left. My outputs are on the right. So -1 is connected to what number? 2. So that would be like the point -1, 2. Do I have a point that agrees with -1, 2? So it looks like I go -1 and up 2. Sure enough, right there. So each one of these connections, each one of these lines makes a connection between 2 points that is actually more than a relation. It's actually a function. Does every x have one line going from it? -1 has one answer. 0 has one answer. 1 has one answer. 2 has one answer. And 8 has one answer or output. Does everybody see that? You can only have one line drawn from everything in the left. So basically, let me kind of give you a little heads up. Write this down somewhere. You can't repeat x's. You can repeat a y. Look right here in my mapping diagram. How many lines are drawn from each one over here? One line, one line, one line, one line, one line, right? How many lines are coming into this number 2, though? 2 lines. So I can repeat an answer, and it's okay. That's not a two-way street. You know how sometimes it's a two-way street? Every x can only have one y, but that doesn't mean that every one y has what? One x. It doesn't necessarily have to work both ways. This is a one-way street. Every x can only have one y. Okay? We don't necessarily like that when it's in our daily lives and it has to do with people, do we? Every girl can only have one boyfriend. But does that necessarily mean that every boyfriend has only one girlfriend? We expect it to be two ways. But sometimes girls or boys will have two girlfriends and only one, so they're violating. It's not. That's what we call a one-to-one relation. Okay. All right. All right. All right. To check if a relation is a function, given the mapping diagram, use the following criteria. Does each input have only one line connected to it? Then it is a function. Or you can use something called the vertical line test. That's a quick and easy, fast way to tell if you have it on a graph. Now, you don't have this, but let's just take a look at a graph. You don't have this, just look at it with me. I think you do have this on the back, don't you? Didn't I type some big notes? Oh, so there it is. Function. For every x, there's only one y value. That means you can't repeat an x value, but you can actually repeat y values. We're going to talk about the vertical line test. Vertical line test can be if a vertical line can be drawn on a graph and only touch the graph one time, then it's a function. If your line that you draw down touches that graph somewhere, two places or more, not a function. So it can't cross back underneath itself. Let's take a look at these two. You don't have these pictures. I didn't realize till I had done mine. But just look up here with me. Okay, guys, look up here. Look at the blue line. Imagine if you drew a line anywhere. Touches once, touches once, touches once, touches once, right? Any vertical line that I could imagine drawing touches how many times? Once. So someone said, is this a function? I could visually just inspect it and imagine drawing lines, and I can say, yep, sure is. What about the next graph? No. Now, if someone said, oh, I tested it, and right there, it only touches once. Yeah, but that's not the whole graph. You got to think of every position on the graph. If I drew my vertical line right here, how many times do I touch it? Twice. So it can't cross underneath itself. Does everybody get that? So this would be a big fat no. You've got some of those on your. I love those because they're pretty easy and fast to say. Is it a function? The answer is no. Look right here. Here's the reason. Remember, every x can only have what? One y. But if I come on this graph, looks like I come into -2. If you come to -2, this point right here looks like -2, comma something. What, about 3.5? 2.5, 3.5? What about this point over here? -2. It looks like I have what? 1, 2, 3, 4, 5. -2 has two answers, doesn't it? That's why it violates it. That's why it crosses under itself. So every x can only have what? One y. So that's pretty much it in a nutshell on relations, or numbers that are connected, and then functions. For every x, there can only be one y. So I want to say that enough times to where it kind of soaks in. All right, again, you don't have this slide, but does everybody kind of understand the vertical line test? It's a quick eyeball test. You look at it, you make a quick decision. Imagine doing a vertical line. If it fails the vertical line test, then you have to say, no, that's not a function. Okay, are we ready for the next page of notes? There are some things written on this sheet, the second page that I gave you, that you're going to need, or it's nice to have them in your 3-ring binder. We will come back to. Okay? All right, pull out your other paper. Here we go. Isaac, Zach, let's do some notes. Domain is a set of all the x values. It is the dependent variable on a graph. What I mean is it's graphed across the bottom. Okay? If you have a graph, it's across the bottom. Okay? It's the dependent variable. Oh, my bad. It is the independent variable. I'm forgetting how my graphs are. Independent always goes across the bottom. Dependent goes up the side. It is also the inputs of the function. Okay. Right here. Fill this in. Range is a set of all of the y values, and it is dependent. That basically means that it's up the side. dependent variables are on the y-axis. Okay, and it is the outputs. It represents what you get out of an equation. Okay. We ready? This is kind of crowded, but I know you can do it with me. It's pretty straightforward, quick and easy. Write the domain and range for the following function. Does everybody see my function? I have a point, 0, 2, 1, negative 5, 2, 8, and 3, 10. I only have 4 points. That's it. Just 4 points total. Okay. I'm going to come over here to the side, and I'm going to say domain, and I'm going to abbreviate it with capital letter D. Everybody got that? You want to make these little squiggle lines, which are actually called braces. And I'm simply going to list every number that's considered a part of the domain. Okay, from my first parenthesis, which one's the domain number, 0 or 2? 0. So 0 is a number in the domain, comma. Look at the next number, 1, negative 5. Which number is in the domain? 1. This is too easy. 2 and what else? 3. Close your braces around your last member of the domain. There are 4 points. Each point has an x value, and each point has a what? Y value. So guess what we're going to do for the next group? I'm calling that capital R for what word? Range. What numbers are a member of the range? We'll go back over here. 0, 2. 2. Negative 5. 8. And 10. Everybody good with domain and range? If I only give you a limited number of points, you pick all the x's, and that's your domain values or your range values. Now, I'm teaching Math 1 right now. Do y'all remember doing problems that that consisted of like coins? Like you got quarters and dimes. Let x be the number of quarters. You need quarters and dimes to make like 85 cents. What is the domain? So it's the values that work to make the equation work out. So in this case, we're kind of taking a new look at domain, but it's still adding to what you already know. All right, example 2 is a table. Do y'all see the table? How many points are in the table? 3 points. 3 of these are what? X's, and 3 of these are? So guess what our domain is going to be? All the X's. 0, 2, and 4. What is all the range values? 3, 6, and 12. As long as the number of points is a limited number, list each one. As long as the points are limited, list each one. Okay. Example 3 is a what? What do we call this again? Mapping diagram, because you will have to know what that is for future reference. Mapping diagram. So everything in the first circle is considered a what? Input, and this is considered a what? Output. Okay. 0, 1, 3, and 9. That would all be part of my what? My x's, which is my domain. My range would consist of what? Negative 5, 4, 8, and 14. Now, you may say, gosh, this is too easy. I don't know why you're talking about this. Everybody good with that? Yeah. Are these functions? Yeah. Okay. Now, what if you didn't have a list like this? What if I just gave you these points? How would you know if it's a function or not? Did I repeat an x? 0, 2, and 4. Does 0 have one answer? Yes. 2 has one answer, 4 has one answer. If there's only 4 points, that's a pretty small function, but it is a function, okay, by definition. Does everybody get that? Okay. I'm moving on to the next slide. We're now going to look at a graph. Finding domain and range on a graph is tricky. Come on. You want to put your hoodie back so you're not quite so warm and so cuddly. We want to make sure everybody's getting this, okay? Domain and range is important. You've got an activity coming up tomorrow where you're going to work with partners and you're going to match up the domain and range of graphs. So we're going to look at graphs starting right now. All right. Okay, when you do domain is across the what?
Y-axis. X-axis.
X-axis, right? It's across the x's. When you do range, you're what?
Up and down.
Up and down. Okay, and here's the best way. I want you to think about farthest x number on the left. Which x number on the left is the least one that I'm doing? And I'm going to go all the way across the graph until I'm going to get to the farthest one on the right. And if it's between negative something and positive something, that's where I'm going to be looking. Does everybody get that? Okay. When I do range, I'm going to imagine my hand coming from the bottom of the graph, or my eye coming from the bottom, and I want the lowest Y number all the way up to, guess what? The highest Y number. All right. I have a question for you. This is between 1 and 2. How many points are between 1 and 2?
1.
Someone said infinite. I heard 2 people say infinite. All right. Why is it infinite points between just 1 and 2 on a graph? That don't look like very far. Exactly. I could break it down into 1. I can break it down into 1, 1 and a half, 1 and 3/4, 1 and 2/3, 1 and 5/6. I could break it down into millionths. I could break it down into smaller. No matter how small you can break it, I could break it down even smaller, right? Numbers can get infinitely small, and I could break it down into small units. So there's an infinite number of values, even between 2 small close points on a graph. When it comes to a graph, you can no longer try to list the points individually. Does everybody hear that? A while ago, I had 3 points in a table. 3! So it's quick and easy to write down that my domain was 0, 2, and 5. That was it. Does everybody get that? But when I have a line, there's no way I'd ever try to say, okay, 1, 1.2, 1.3, 1.4, 1.5, 1.22, 1.23, 1.24, 1.25, 1.2. I would never, ever try to do that. So what I'm going to have to do is I'm going to have to learn to use notation. Y'all ready to learn some new notation? Okay. We're going to have to learn what's called between. You ever heard of between before? Okay. I would say between 1 and 2 is all of the numbers that I'm interested in. Do y'all agree with that? I'm going to start at 1. I'm going to go to 2, between. And that way I've kind of left myself, that's a good way of saying, that includes every possible number you can think of that's in the middle between those points. Does that make sense? Okay. But with mathematicians, you know we love math symbols. Okay? How about, could I say it this way? I want every x that's what? Greater than or equal to 1. If there's a closed circle right there. Do you remember closed and open circles? We're going to revisit that idea. Or I could say, and it has to be what?
Less than 2.
Less than 2. Everybody good? Okay? I want every x value that's greater, and okay, I'll say equals because it's a closed circle. Every x value bigger than 1, and I want the x values also what? Less than 2. That kind of restricts me to right here. Does everybody get what I'm saying? This is called between notation, and I'm going to train you to do it right now. Training you. As long as it's domain, x goes in the middle. What's the smallest number? 1. What's the biggest number? 2. Here I'm training you right now. Which direction does, on the biggest number, 2, which direction is the arrow facing? Pointing to the x, right? So it's going to point to the x still. Does this side still look like that?
Yeah.
Okay. Now this one over here is backwards, isn't it?
Yeah.
If I flip this over, I'd have to flip everything over, even the sign. So, right. So it's pointing to the what? No, this one's pointing to the 1, isn't it? Okay, so it still has to be what? Pointing to the 1. This is called between notation. I basically took 2 inequalities and squished them together. And you say it like this. X is in the middle between what? 1 and 2. Now, it's always like this, always. Let me make sure you get this. Backwards, backwards. Always. Always, because of how the signs are. Bigger than my smallest number, but less than my biggest number. Does everybody get that? So if you combine that, it's always backwards, backwards. So if you learn that right now, your life is a whole lot easier.
Backwards.
Now, sometimes you use an equals, and sometimes you don't. Do you know the difference between when you use an equals and when you don't? It's less than or equals, or if it's greater than or equals, what do? You'll see a what? Closed circle. Somebody was saying it. I heard you. What if it just says less than or greater than with no equals? Then you will be looking at a what? An open circle. All right. So does everybody understand? When you see a graph, you cannot list the domain numbers individually, can you? You can't say 0, 0.1, 0.2, 0.3, 0.4, 0.5. You can't do that. So we have to start looking at mathematician's notation, and I want you to learn between. Okay, now let's go. Let's go to the next slide. Everybody looking at continuous function? Okay. When it's continuous, that means a line is there. We have a line graph, don't we, Zach? Yes, we have a line graph. All right. The domain, and I think I went back and on your copy, didn't I make this a nice big black circle? And this one up here is a big black circle. Here's the first thing I need you to do. I'm looking at domain and I'm looking at range. I'm looking at domain and I'm looking at range. Let's tell me the coordinates of this point. What is this point? -5, -3. Okay. Tell me the coordinates of that point. Over 3, up 3, 3. Okay. Obviously, 5 is an x value and 3 is a what? X value. This one up here. This is a y value, and this is a y value. Remember how we're going to focus. If I'm doing domain, I want to go farthest to the left to what? Farthest to the right. What's the farthest to the left x value that's on this graph? -5. So right here in my blank, notice that they've got x already in the middle. They got backwards, don't they? They even have an equals and an equals with them. Do y'all see that? So this first one's set up for you. Okay, -5 goes on the left. What is the biggest x value? How far does it go? Stops at 3, right? So this domain is all of the x's between -5 and 3.
The y's would be all the y's.
Okay. The range would be all the y's. I want you to imagine lowest y value to what? Highest y value. So what's the lowest y number that's being used? -3. Okay, I agree with that. What's the highest y value that's being used? +3. Have you done this before? No. Notice what letter's in the middle. If it's range, what letter should be in the middle? Y's, because x is our domain and range is the what? Y's. And notice that this is a continuous smooth line. It's a continuous function. There's no way we can ever list a point individually. So this is a mathematician's way of saying every number between and including -5 and including 3. Every y number between -3 and 3, including -3 and including 3. Does everybody get that? So it does touch at -5. It does touch at +3. It does touch at -3, and it does touch at +3. You're actually touching and landing on those points. It is different, isn't it? Is everybody okay with the first example?
Yes.
Okay. All right. Now let's go to one. Oh, is this a function? I need a quick yes or no. Yes, because if you imagine the what? Vertical line test, it passes. Next one. They did not write it for us this time. If it's a simple graph like this, can we find the points first? That's always a good way to help us. What's the points? -6, 4. Yep. Over 6, down 6. Everybody good?
Yeah, but it ain't closer.
All right. And we have an open circle this time, so we do not need an equals. But up here we have what? A closed circle. So on one side we'll need an equals, and on the other side we won't. All right. If we're doing domain D, what letter goes in the middle?
X.
X. If we're doing range, what letter should go in the middle? Y. Okay, remember I said I was training you. Smallest x on the left, so go to the farthest to the left. What's the smallest x? -6. So -6 is my left-hand number. How far right does it go?
6.
It goes to the other 6, right? +6. Everybody get that? All right, I said I would train you. What do the signs always do? Always. Backwards, backwards. They always go backwards, backwards. I think we talked about that, didn't we?
Yeah, I wrote it down, but I don't understand it.
Okay, right here. Remember how we said it's in front of the 1, but it's behind the 2? So it's pointing one direction toward the number, but then it's pointing what? This is pointing backwards. What I did is I flipped it. This part come from here, and this part got switched, and it's like I went.
So you switch both up?
Yeah, they always go backwards.
You didn't switch.
I did. This one I didn't because it's pointing to the X, right? Hey, look. Right. See, I did. One has to come over to this side, so when I brought one over here, where did X have to go? See? This is actually two squished into one. Do y'all see two different ones there? Do y'all see two different inequalities? The left-hand side comes from this one, and the right-hand side comes from what? I just put them together. But when I put X in the middle, X is on the left, and X has got to be where? So I basically took this and went what? Flipped it. And when I flipped it, it's pointing to the 1, and it's still what? Pointing to the 1. Now it makes them backwards. One side needs an equals. Which side? Does -6 have the closed circle as +6? Nope. +6 has an open circle for X. So it's -6. On this side, I need an equals. On that side, I do not need an equals. Everybody understand the equals? Okay. Anybody got the range figured out? So lowest Y number? -6 is the lowest. Always go from bottom to top. Highest is +4. The signs are always what? Backwards. Look carefully. Which side needs the equals? Does it? The Y of 4 has a closed circle. So where the 4 is, you put a line on it. Okay. Is this a function?
Does it matter what order you put them in? I put 4 first.
No. It should be lowest to smallest, or lowest to biggest. Yeah. You got to put them in order. It should always go smallest to what? Biggest. It's got to be that way. Otherwise, your signs are backwards.
So the open and closed circles don't affect it.
Don't affect what? The open and closed doesn't affect with its function. Okay, what about this one? This is a different example. On this sheet, I just so happen I see this. Do y'all see a handwritten note at the bottom about arrows? What does an arrow mean on a graph? That it goes forever and ever infinitely, right? Now, I need you to imagine this arrow. Where are you going? Don't go this early.
What?
Said you don't need to go this early.
Actually, no, it said 4. Oh, it said 35.
Yeah, you're a little early. Okay. All right. This arrow is going down and to the left. Does everybody see that?
Yeah.
So if I broke it down into an X direction and a Y direction, is it going farther and farther and farther to the left as time goes by?
Yeah.
Is it also going down as time goes by? So you could say that this arrow is showing me that this graph is going to the negative direction toward what number? What do we call it when we go to bigger and bigger and bigger numbers? All the way to, starts with the letter I. Infinity. Do you know how to make an infinity symbol?
Yeah.
It's like a sideways 8. So this is going to negative infinity. If you go down, and that's in the X direction. So my X's are going to negative infinity in the X directions. Everybody get that?
Yeah.
Okay. What about this little, well, it's like I'm breaking the one arrow down into an X direction, Y direction arrow. So break it down. All right, what about this one? It's going to negative infinity and the what? Y's. Yes, I do want you to draw that. Okay. Now, I not only see an arrow on the left, I also see an arrow what? On the right. Where's this arrow taking this function to? So if I break it down, this side's going to positive infinity in the X's. And it's also doing what? Still going negative. It's going down. Infinity on the Y's. Everybody good with that? This is going to be tricky. All right. What do the arrows on the ends of the graph mean? Going to infinity and beyond. Okay. Is this a discrete or continuous function? It is continuous because it doesn't stop. It's asking me for the domain. Now, remember, when you do domain on a graph, you go farthest x's to the what? Farthest to the right x's. How far do you go?
Infinity.
To negative infinity. So I'm going to write that down. Negative infinity is my smallest x's. They're getting super, super small, but they're going in the negative direction, super, super small. What about the x's on this side? How far to the right? Positive infinity. What letter should go in the middle? X's. Now, I will tell you this. You never have an equals on an infinity because you never know what number that infinity is. So if you tell me what number infinity is, I can tell you one number bigger than infinity. So it's backwards, backwards. Now, does everybody understand what we just did? Guys, this is not the answer. This is correct. This is not the answer you'll see on a test. Because what you're saying is every x number is being used, right? Every x number, like negative 8, is going to come down touch. Even negative 10, if the graph goes down far enough, would touch, right? Negative 11 would touch. Negative 20 eventually would go down and touch. Y'all see what I mean? No x values left out. Every x value is being used. So we simply change that to a phrase, and what do we say? All real numbers. And some people don't even want to write that much. They write one letter, and that's enough. It's actually a big, bold R, but it's kind of got like, if you write it shorthand, it's almost like got two sticks on the front, and you could say all real numbers. Typically, a lot of mathematicians will put two sticks on the front, and that indicates that's one letter symbol, and what does it mean? All real numbers. Because you're saying every x to negative infinity is being used, and every x to positive infinity is being used. And the shortcut is, if you have arrows, do you see an x going in that direction? And the other x is going in that direction. If you have arrows in both directions, always all real numbers. Okay? Everybody okay? Okay, are we ready? Let's do range, and we'll go to lunch. We'll do range and go to lunch. Range. What letter goes in the middle? Y. Now, this one is not all real numbers. I'll give you a hint. Okay? We're going to go from the lowest on the graph to the what? Highest on the graph. And this one stops at some high number, doesn't it? How low does it go? From negative infinity. It's coming from negative infinity. It's so low, it's way down there at negative infinity. Right? But it does come up, and it does come up, and it does come up. How high does it come? And 4. Does it actually touch the graph at 4? Yeah. We're going to, if it looks like it touches the graph somewhere, you're going to call it that number. So it only goes as high as 4. What are the signs? Always. Backwards, backwards. Now, does it actually touch at 4? Yes. On a test, you probably won't see the infinity side. You will actually only see this. This says what? It's every y number from 4 down. Did I get that? All right. Is this a function?
Yes.
Yes. So we learned really some new stuff. We're going to pause there, go to lunch. All right, we're back from lunch. Let's go ahead and get our notes finished. We got a couple more to do. I'm going to let you do this one. Only thing I'm going to suggest is that you find all of the points. And then you decide what's the farthest x to the farthest x to the right, lowest y to the highest y. And this is a circle. So you're going to come up with coordinates of 4 points, but you will not need every number. Okay? All right. Let's do it together if we're stuck. We shouldn't be stuck. I'm going to find the coordinates at the top. I go over 3, down 1. So 3, okay? 3, negative 1. On the right, looks like 7 down 5. Y'all find, are you seeing these the same as I? Okay, and down here, the coordinates would be what? 3, -9. And then on the left is -1, -5. Everybody good with that? So I have, if I'm looking at x values, I have -1, 3, and 7, and then a repeat of 3. Does everybody see that? You will not need all 3 of those numbers. Okay? So if I'm looking at my domain, what letter should go in the middle? X. What letter should go in the middle if it's range? Y. So when I do domain, I want farthest to the left to farthest to the right on the x-axis. So what is the lowest x number? What's the farthest to the right x number? -1 to as high as 7. So -1 goes on the left of x, 7 is on the right of x. Remember I said I was going to train you? How do you do the correct notation for between? Signs go backwards, backwards. They always go backwards, backwards. Now, I need to look closely. Does it actually touch at -1? Does it actually touch at +7? So you need an equals and an equals. We've now completed the range. Let's do the domain. All right. Y numbers. I see -9, I see -5, and I see -1. You will not need all 3 numbers. I want farthest to the lowest to the bottom, farthest to the bottom, to highest to the top. Okay? So, what's the lowest? Well, it's going to be a number in the middle, but it's not the lowest or the highest. So I just need the lowest and the highest. So what's the lowest Y number that's on the graph? -9. And then there's a lot of points in between. What's the highest Y value? So -9 should be on the left, -1 should be on the right. It's always the smallest on the left. It's always the biggest numbers on the right. All right, we're going to train you again. Which way do the signs always go? Backwards, backwards. And does this need an equals?
Yeah.
Yes, I do touch and I do touch. Yes or no? Is this a function? That's a big no. Obviously, it fails the vertical line test in many, many, many places. Everybody good with this example? Okay. So you kind of get more comfortable with what's the domain and what's the range. We'll be practicing this some more tomorrow. All right. Last one, try on your own. I'm going to pause the video. All right. So, did we all get those answers? All right. So this wraps up the notes for domain and range.